So one guy who messed around with cathode ray tubes a lot was J.J. Thomson. J.J. Thomson was an English physicist who did a ton of stuff, including almost single-handedly starting the field of nuclear physics. Thomson notably did an experiment with the cathode ray tube, which led to the development of television. At this point, people really just knew that if they constructed a glass tube with wires at both ends and created a vacuum inside, a beam of light would pass through the tube and the wires would glow and a voltmeter would register a charge. Thomson set out to investigate the beam via the famous cathode ray tube experiments. In his first experiment, Thomson applied a magnet that directed the beam away from the electric charge readers, and since the voltmeters didn't register anything, thereby proved that the beam and the charge were completely inseparable, which was a revelation at the time. In the later experiment, Thomson basically deduced the size and charge of electrons from the deflection of the beam within the cathode ray tube when the beam was exposed to differently charged anodes and cathodes. This required lots of math and careful readings and so much patience. So basically, Thomson used these cathode ray tubes to literally figure out that electrons are a thing, how large they are, and how much charge they have. And now finally we get to televisions. Well, old televisions. Not the new ones you kids are messing around with these days. So basically, inside a television, there's a cathode ray tube. The TV is coated with light-emitting phosphors, and the cathode ray is guided by magnets to different parts of the television screen to hit different phosphors. The magnets figure out where to guide the cathode ray based on information that television receives via signal, typically transmitted through an antenna. The cathode ray goes line by line down the television screen, hitting different phosphor-coated dots on the back of the TV screen, and in the end you have a pixelated image, which your brain turns into a picture. In a black and white TV, there's a single cathode ray, and hitting a phosphor makes the screen white, while not hitting a phosphor at all makes the screen appear black. Color TVs work almost the same way, except that there are 3 rays, and the phosphors emit red, green, and blue light. So in this video, you learn that electrons are a thing, a very important thing. You also learn that electrons jump around on energy levels and are arranged in 4 types of orbitals. You learn that light gets emitted when electrons jump between energy levels and what a hybridized orbital is. Finally, you learned what a cathode ray tube is and how beams of electrons are responsible for TVs. Thank you.